everyone, this is just an additional recording of the online class today that I did. I think lab reports are really important because they are 40% of each unit's grade. So basically the lab counts the same as your tests and quizzes. So it's really important that you make sure that you understand what I'm looking for on the lab, and really everything that I'm looking for is already built in to the lab. So you can take a second and enjoy my little chemistry meme. How often do I like to joke about chemistry? Periodically, ha ha ha. Alright, let's go ahead and get started. Alright, so I'm going to talk about how to get to your lab file. Most of you know how to do this, but some of you need some help, so I just want to make sure you know what to do. You're going to open up your lab from your assignments. You should be able to see this little box that says download attached file. You're just going to click on the download attached file. When you do that, then this little box should pop up in Microsoft Word, if that's what word processing thing you have. That's what most people have. Make sure you click that enable editing so that you can actually write on the lab. And just for the record, it really is okay to write on this as you're doing the lab. There's nothing wrong with writing it as you go. You don't necessarily have to do everything on a separate sheet of paper. You can just write as you go. So to complete your labs, if you're a chemistry or biology student, you use your late night lab information. If you don't know where to find it, look in your email. It should be from your education coordinator, and that's who you need to contact if you can't find it. If you're integrated physics and chemistry or physics, you're going to use the fet.colorado.edu. You don't use any accounts for these. You just open it in a web browser for free. All right, so let's go ahead and look at the rubric first. Using the rubric is a really great idea for any class because that shows you how the teacher is going to grade. So a rubric has just been set up, and that's kind of what we use to categorize, how well was your hypothesis, how good was your data. It's how we make sure that as a science department we grade all labs the same. So it shouldn't matter whose science class you're in, you should get the same grade because we're all using the exact same rubric. So when you're in any class, if a teacher gives you a rubric, go and be sure to look at that, because you should be able to take the rubric once you're done writing, and you should be able to assess yourself and kind of guess what you're going to make. So we're going to do this kind of section by section. We're going to go through the different categories first of where you can score. So you can either score strong for 10 points, developing 6 points, emerging 2 points, or it lacks merit, which is 0 points. Now sometimes I'll highlight two different columns. So say I highlight on conventions strong and developing. All I mean is that I'm giving you the middle score. So instead it's not quite 10, but it's not quite 6 either, so I assign 8 points. So if I highlight the first two columns, it'd be 8 points. If I highlight the two middle columns, it would be 4 points. And if I highlight in between 0 and 2, then it would be 1 point. So we're going to go through each different section on your lab. There's 10 sections that you're graded on. Each one is worth 10 points. The first section is conventions. This really should be pretty easy points. This is just making sure that you wrote with proper grammar. So conventions, the writer demonstrates a good grasp of standard writing conventions. We'll go through what I mean by that in just a second. Hypothesis, to get full points, it clearly identifies the independent and dependent variables, uses the if-then format. That if-then is really important to get full points. Then procedure, it's written in first person past tense. And what I mean by first person past tense is you use I as the subject, so you start your sentence with I, and then you use a verb that's past, or it has ed at the end. So I did, I went, I took, it's something that happened in the past. So you're writing this in first person because you did it. So you'll say I did this, then I did that, to help write it out. And again, Your procedure should be step-by-step directions. It can be in paragraph form. You don't have to put 1 dot, 2 dot, and then write out what to do. It can just be in a paragraph form. So step-by-step directions that could be used by another person to successfully complete the entire project. A lot of people don't really write their procedure with that in mind. So let's look a little bit more carefully at these sections. I mentioned again, like I said, this is really just using correct grammar. So did you capitalize the beginning of your sentence? Did you use the right punctuation? Did you spell things right? Stuff like that. And in Microsoft Word, if you spell something wrong, it should give you a little red squiggly line. So whenever you're done, before you turn it in, just go see if you have any of those red squiggly lines and fix them if you need to. Then your hypothesis. So the place where I see the most points missed is just because you don't have a full hypothesis really written. So your hypothesis is only going to be 10 points, but sometimes your hypothesis, you should have more than one hypothesis. So make sure you have all the hypotheses you need. You need a hypothesis for each part of the experiment. So look through your lab, and then if you see part 1, part 2, part 3, then you know you need to write 3 different hypotheses. So you should have 3 different if-then statements. So each of your hypotheses would begin with if and end with then. So it should say something like, if I blah, 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 then blah, 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 blah will change. Just fill in the blah, blah, blahs with words. And those words should relate the variables of the lab. So it should actually tell you, if I do this, then this will happen. And it should tell you how you're changing something and how you think it's going to respond to that change. If you're trying to figure out, okay, I'm not sure what I'm supposed to measure and I don't know what the variables are, a really good place to look is the goals section. That's at the very, very top of your lab. It's the first thing that's written there. It says your goals. So we're just going to go through some example hypotheses, kind of on the scale from 0 points to 10 points, how I would grade it. And hopefully that'll let you see how to write a really good hypothesis. So I'm going to use the density lab. This is one, if you're in integrated physics and chemistry, that you should have already done or you'll need to do in the first unit. And remember, your hypothesis is supposed to come first before you do the lab, not after. So if I was trying to figure out what to write about and what I'm supposed to be guessing, the first place I would look, like I said, are those goals. And one of the goals for this lab was to explain the relationship between density, mass, and volume. So my hypothesis should explain or predict what I think the relationship between density, mass, and volume is going to be. So the first one we're going to look at is kind of an irrelevant hypothesis, and it says if the water rises, then I can find density. In the lab, if you've done it or if you look at it, you have to take a block and put it underwater, and however much the water rises, that'll tell you the volume of your block. Now, that's not really, while that's something that happens, it's not really something that we're looking for in the lab necessarily. It's not the main purpose. So an irrelevant hypothesis would be, if the water rises, then I can find density. Number one, if the water rises, it's only going to tell you about the volume. It's not going to indicate the density. So this statement doesn't even really relate, but my hypothesis should be relating density, mass, and volume. And I just say the water rising, so that's not really right. Another example would be, if I do the lab, then I will find a relationship between density, mass, and volume. Yeah, this is an if-then statement, but it really is just taking the lab and putting if and then in the sentence. I don't really think that there was a whole lot of thought if someone made this hypothesis. Someone said in class earlier that it's kind of just a cheater hypothesis because you just copy and pasted it. Again, this person says that there is going to be if I do the lab, then I will find the relationship. Obviously, there's going to be a relationship, or we wouldn't assign the lab. A better hypothesis, so this would be the 6-point category, would be, if I can measure the mass and the volume, then I can determine the density. So this is actually kind of relating the density, mass, and volume to density. It's just not saying how mass and volume affect density. So that's why it's not a perfect 10, is that it says that I can use mass and volume to get my density, but it's not saying how mass and density are going to affect how much density the object has. So here's an example of something that's really good, and it's two parts. So if an object has a small mass and a large volume, then the object will have a high density. So right there I'm showing this is what I think and how I think the objects, or not the objects, how I think mass and volume will affect density. I'm actually predicting the relationship between density, mass, and volume, which is my goal of the lab. I also say if I can determine the density of an object by measuring mass and volume experimentally, and experimentally just is a fancy way of saying I did it in the lab, then I can determine what the object is made of from a table of known densities. So this shows that I actually went through the procedure and saw that I was going to be looking at different objects and figuring out what they were from a table that was given to me. So whenever you write your hypotheses, it's also a good idea just to go through the procedure and see if there's anything that you're going to use and let that help you. So again, these are just a few examples. Hopefully that helps you see how to write a better and a good hypothesis instead of just kind of copping out and doing the bare minimum. Alright, so on the procedure, like I said, someone should be able to read only your procedure and repeat the lab. It should say something more than I just followed the directions. If I were wanting to put together, a piece of furniture and someone just handed me directions that said I followed the directions, I wouldn't know what to do. So same thing, if you are writing a procedure for a lab and you say I follow the directions, that's not going to let someone know how to actually get the results that you want. A really good way to see if you did this is ask yourself if you could redo the lab with only your directions, or ask a sibling or a friend or a parent to read through the procedure and see if it makes sense and see if they could actually get the lab completed. You don't need to explain how to calculate anything in this section, you just explain how to collect your data. So for the density lab, for example, you have to calculate density at some point. I wouldn't say in the procedure I would not say this. I calculated density by dividing mass by volume. Instead, I would say something more like, I collected mass by putting the block on the scale, and then I calculated the volume by putting the block underwater and seeing how much the volume changed. I used those numbers to find the density. So you don't want to necessarily tell the person how to calculate everything because, you want them to grow and learn in the lab as well. And these are just some directions in every lab report. So when you open your lab report, when you go down to start to write, there's a little italicized part and it says exactly what to do. So the stuff that I'm going over right now, it's already been given to you. I just want to point out what it means and show you, hey, here's what you need to do to get a perfect grade. So hypothesis, a prediction of what you think the results of the project will be. Write your hypothesis before you begin the experiment, and if the experiment has more than one part, you will need a hypothesis for each section. Remember to create an if-then statement. So that's exactly what I just went over with you all. And then procedure. In first person past tense, so like I did or I took or I did that, write a step-by-step of what you actually did in performing the experiment. If you had to change anything to get the results, be sure to include that as well. You should include enough detail so that someone could reproduce the experiment based on what you have written. So again, that's exactly what we just went over. Alright, let's go ahead and move on to the next section. So we've gone over 30 points of the lab so far. The just writing with correct grammar, that's 10 points. Hypothesis is 10 points. Procedure is 10 points. Next, we're going to go over data, which total is 20 points, and calculations and interpretations, which is 20 points. So another 40 points of the lab. So this is a really important section. It's worth 40 out of 100 points. It's important that you do well. So completeness of data, I'm just going to go through the 10 points category. All data is recorded with unit labels. Just means you have your units written down. All observations are duly noted. That just means that you wrote down what you saw with detail. Accuracy of data. All data is measured to the correct precision and recorded with the correct units. Observations are accurate. Then your calculations. All calculations are shown, labeled, and correct. And then interpretations. All questions are answered correctly. Interpretation of data is evident. We'll just go through each section piece by piece. The completeness of data, that's 10 points. So this is really just, did you record all your data and observations? Did you fill out all the charts if you had charts? Did you include units? So instead of writing 58.0, did you write 58.0 grams? So make sure you include a unit with your numbers. Then accuracy of data, this is another 10 points. So did you do the lab correctly and get the numbers you were supposed to? When you recorded your unit, did you use the right unit? So did the lab say kilogram, but you reported grams? Did you use the right unit? And again, here are the directions that are in your lab report when you open it up. It says describe all observations or changes, list all measurements, and include proper labels, which just mean units. Then on the calculation section, again, this is another 10 points. The thing you need to think about here is, did you show work including the formula, the numbers you plugged in, and the answer with units? So here's a little quick example. If I was going to solve for density, you can see I first wrote the density equation, D equals N divided by V. Then I wrote in what numbers I was plugging in. So D equals 25 grams divided by 5.0 milliliters. And then I wrote the answer, density equals 5.0 grams per milliliter. I showed the formula, the numbers that I plugged in, and then my answer with the correct units. Make sure you showed all your calculations in your lab, or at least an example of every different type of calculation. So in this density lab, for example, it said show one example of a calculation. So you would only show how you got density for one of your objects. And then sometimes there won't be number calculations on your lab. If you didn't have to do calculations, don't worry about it. Kind of just like 3 points. If you're unsure if you were supposed to do number calculations and show them, then just ask your teacher. There's nothing wrong with asking. Just say, hey, I didn't see any calculations. Is that correct? Better to ask than to get something wrong. Again, here are the directions on this section in your lab report. It says show all math performed. Label the calculation or give the formula, show your setup, and give the result. Include proper labels and or answer any questions. Questions are the interpretations. And this is just, did you answer the questions correctly? Did you answer all the parts to the question? So sometimes a question will really have 2 questions in it. So did you answer both of them, or did you just answer the first half? And then when you answered the question, did you explain your answer fully? Did you just say like yes, no, or did you say yes because of, and then fill in the blank? And then here's where most people have the most trouble. So here's where you need to get help if you're really struggling with understanding what you were supposed to learn in the lab. Because once you get to the interpretations, you should know what to write. It's okay to ask for help. It's okay to call and ask if you're unsure of an answer. We want to help you. We want you to get the best grade that you can. So it's better to get help before when you're writing than to get it wrong and lose points on your grade. So anytime throughout the whole lab when you have a question and you don't know what to do, you can call. If it's from writing the hypothesis to you don't know how to do the procedure or what to click on or how to get the numbers or what to put in your data table or how to do a calculation or what your units should be, or you don't understand an interpretation question, then just call and ask for help so we can help you. We want to help you. If we don't know you need help, then we don't know you need help. And then the last section I want to go over is the conclusion. So your conclusion is 30 total points. That's a lot. It's almost as much as the data and the calculations and the interpretations combined, and it's just one section. So it's 3 different parts in your conclusion. So number 1, your conclusion is relative to the hypothesis, or your statement clearly shows that you understand the relationship between the hypothesis and the conclusion. Your conclusion includes adequate evidence to support the hypothesis, meaning your evidence presented is complete and clearly sufficient to support or refute the hypothesis. Again, we'll go into more detail in just a second. And then a concluding statement, and I want to make it clear right now, a statement is not just necessarily one sentence. It can be several sentences. It's okay. So concluding statement shows complete understanding of the project by the student. So let's just go over a little bit more detail what I look for in conclusion, because this is typically the weakest part of lab that I have seen right now. So the rubric says it should be at least a paragraph. Please know that a paragraph is more than 3 sentences. A 3-sentence paragraph is used for elementary school kids that are just learning to write. A high school level paragraph should be at least 10 sentences long, and it should be 10 good sentences, not like, I went fast, I did this. They should be well-developed sentences. And again, it counts for 30 total points. This should be where you prove that you learned stuff. I should be able to look at your conclusion and know exactly what you did. So in real science, if I was going to try to figure out, if I wanted to look at someone's work or their research, the first place I would go look is their conclusion. But because their conclusion should tell me what they were searching for, what they found, how they found it, the proof that they found it, and then any concepts or relationships that reveal themselves through their experimentation. So yours should do the same thing. I should be able to read your conclusion and know everything that happened in the lab. All the highlights, all the big points, all the big things you were supposed to learn. So your conclusion should tell the audience, again, everything you thought was going to happen. So this is your hypothesis. Just restating your hypothesis. And then what actually happened in the experiment. So that's like the first 10 points, or that first section on your conclusion rubric. Okay. The next part is showing how you know that happened, and you need to use specific data. If you just say, my hypothesis was right because that's what the lab showed me, that's not being specific. You need to use real data and real observations, be as specific as possible with what really occurred. Because if you don't, I don't know if you really did the lab, and I don't know if you understood what happened. And so that's 20 points. The next thing is you should explain any concepts that you were supposed to learn. Again, there's a reason you're doing the lab. And if you're not sure what you were supposed to learn, then go back up and look at the goals. The goals tell you what you're supposed to learn. So your conclusion should prove that you met those goals. Another really great place to look are the interpretation questions, because those are where you're trying to figure out why everything occurred. So a great thing to do is to take some of those really good interpretation questions and turn your question and answer into just one sentence. And then lastly, you should talk about any ways to improve the lab to reduce errors. And when I talk about something to improve, I don't mean say something like, I should have been more careful when measuring mass. It shouldn't be something that you could have easily gone back and done again. It may be something like, something that could have improved the lab is if the scale read to one more decimal place to be more precise. That's a way to improve the lab. Just saying that you needed to be better at measuring, that's not an improvement to the actual lab procedure. So you're thinking about procedural things that need to be improved. And always try to think of one for your lab. And then real quick, something else is that you don't need to talk about if you like the lab or not. It doesn't help your grade, nor does it hurt your grade. If I start seeing a sentence that says, I really liked the lab, I don't read it. I feel like most people say it because they're just trying to add fluff and fill to their paragraph to make it look longer because they've run out of things to say. But you should have a pretty good idea now of what to say in your conclusion. Your conclusion should be the best part of your whole experiment because it tells you what you thought was going to happen, what actually happened, how you know based on your data, and it uses your real data. You explain any concepts, and you talk about ways to improve it for next time. It's just a big summary. So you don't need to tell me if you liked it or not. I think it's great if you did, but the purpose of the lab was to help you learn, not necessarily just to entertain you. I know that can sound kind of mean, but it's the truth. Then again, this is just a direction on every lab report. It should sound very familiar because we just went over this. So everything I'm telling you is already in your lab report. I'm just going over it with you. So, conclusion. Begin by stating whether the hypothesis was true or false. Use data and calculations to support your answer. Consider the following questions as you write your conclusion. Why or what happened to result in the outcome you observed? Did you learn anything new? If not, what previously learned concepts did the lab reinforce? Is there anything you would or could do differently that would improve the experiment? Do you have any other comments or observations you want to share? Your conclusion should be 1 paragraph in length. And again, a paragraph is like at least 10 sentences. So here's an example of a really good conclusion. Again, I had got permission to use this person's work. You can see right here, it's incredibly detailed just by looking at the length of it. It also helps, this is just a side note, if you write all your answers in different colors, because I can visually see where you start and where you end, and just make sure I don't forget anything. So this person starts out, all of my hypotheses were true. She says what her hypothesis stated, if it was true or not, and then her evidence using real data from the lab. And then she actually went on to explain why it occurred. And then her second hypothesis, she did the same thing. She said what happened, or what she predicted happened, if it happened, and then how she knew using real data. So her explanations of her hypothesis go all the way down till about 6 lines from the bottom. So she did a really good job of explaining her hypotheses, if they were true, and she used the data to explain why she knew it was true. And then she says, I already knew most of the things in this lab, such as the basics of mass, volume, and density, but I never thought about some of the things, such as in my second hypothesis, and she goes on to explain why. She says there isn't anything I changed in the experiment. It was kind of fun. It helped me to visualize some of the concepts. So even this conclusion, even though it's more than 10 sentences, I still gave her advice, because just saying it visualized the concepts doesn't tell me that she necessarily understood the main concept of the lab. So I told her this is a wonderfully written conclusion. It's one of the best labs that I've read so far. I'd really like to use it as an example if it's okay. The only thing I would add is a simple sentence saying the relationship between mass, volume, and density. Something like density increases as mass increases and volume decreases. So make sure before you are done with your conclusion, you scroll back up to those goals and make sure you've explained in detail the relationships that are there. And then here's an example of a conclusion that needs work. It's just these 4 lines. And it says, I did not learn anything new because I have done these things in the past, so what I expected came to be, except for 1 or 2 things I was off by a few numbers. And again, this might be true. This person may completely understand everything in the lab, but I need proof in words that he does that, or that he knows that. So I put in the comment over here, so what were your expectations? What did you already know? He goes on to say, this lab reinforces many things. And I say, like what? Don't just say the word things or concepts. Explain what those things are. So again, he says, this lab reinforces many things. By now, what is in the experiment is common knowledge on how the waves and velocity works. So I ask another question here. Well, how do they work? And he goes on to say, if there was a horizontal option where I could shove the string back and forth, it would help me with more projects. So he was kind of thinking of a way to improve it, but he didn't say what he would do with it. So I commented, what would you do with that? And then I just gave another little comment that said, your conclusion didn't address your hypothesis. If you look through, he doesn't once say my hypothesis was true or false because of this. So it didn't address the hypothesis, it didn't address the goals of the lab. And I copied the goals down here to say, and they said, explore the relationship between energy, amplitude, frequency, and wavelength for a transverse wave. So somewhere in this conclusion, he should have explained the relationship that existed between those 4 different variables, because that was the goal of the lab. Another goal was to develop a mathematical relationship, which just means an equation, between wave velocity, wavelength, and frequency. And so I told him you should have talked about all the relationships and explained them. You should have also included an equation to solve for velocity using wavelength and frequency. Disregard my little typo right there. But you can see there's my little red squiggly line. I should have gone back in that and fixed that before I sent it off. And then lastly, I'm going to talk about writing and turning in your lab report. So it really helps, like I showed you with that one example, if you write your answers in a different color other than black. Now this is only going to be for your science labs, so don't do it for other classes. This is just for me. It helps us as graders see your work more easily so we don't miss something in between sections. Make sure you write in the lab template. You can do this as you work through the lab, as I mentioned earlier. Make sure you upload your document correctly. This is where people struggle. So I'll go through how to do it. So make sure you upload the completed lab report, not just the template that you got from your assignment. So it helps if when you're done filling out the lab report, you go to Save As instead of just clicking Save, and then click on either Desktop or My Documents and save it as a new file with this format. So last name, lab title. So I might do Ellis_density. And that way when you go to find your file, you know which is which, and you know that yours that is completed is actually the one that's completed. And then please use a .doc or .docx file. So if you use Microsoft Word, it should do it automatically. So when you go to your lab and you download it, this will pop up. This is actually on either page 2 or 3. You're not going to write anything on this lab until after you write your student name, so your name, the date, and my name, the name of the grader. So you're going to start writing underneath the hypothesis, and that's where you'll write your hypothesis. Then you'll go to the procedure, and underneath the procedure section, that's where you will write your procedure. So all of your lab should be in each different section. If you get to the interpretations and you have questions, answer each question after the question is asked. Don't do it in like one big series. Just answer each question as they come. When you go to upload the file so that I can grade it, you're going to go back to your assignment. You're going to click the button that says Browse. After you click Browse, this little window is going to pop up that says like File Upload, and then you can go to wherever you saved it. So I am in my documents and integrated physics and chemistry and my labs, and then you're going to pick whichever lab that you want to upload, and then you click Open. Once you've clicked Open, it'll appear in between the Browse and the Upload, but you still have to click that Upload button to actually do it, and then where it says No File, your file name should occur. Alright, the last thing is viewing your comments after your lab is graded. I spend a lot of time giving you all feedback on your lab so you can hopefully improve and get better as the course goes on. So make sure you look at those comments. So you're going to go to the assignment. Where your file was that you uploaded, there's going to be a new file. It'll say like your last name, the lab, and then graded in all capital letters. You're going to download it just like you or you're going to just click on the file name. You should download it, and then when it opens up, make sure you hit Enable Editing again, and then my comments are going to be in the right-hand margin. Again, I'll show you what it looks like. Make sure you also get down to the rubric to see how it was scored. And then if you have questions about the graded task, giving you feedback is to help you not make mistakes again, but I could have missed something. Comments will be in this right-hand margin. It says comments, so if you don't click Enable Editing, sometimes it doesn't pop up. If you can't see my comments, make sure you tell me. And then the rubric grading, so this is a rubric I highlight which section you have. Again, if I highlight 2 sections in the same row, it just means you got the middle score. So this was 2, this was 6. So I gave 4 points total. Then at the very end of the lab, I will put your score at the bottom. You'll also see the score in your assignment in Ignitia. Okay. If you have any questions, please just give me a call or shoot me an email or send me a message. Come to office hours, whatever you need. I don't want you all to be frustrated by labs. It should be a fun experiment, and I don't want you to have problems. So I hope you all have a great day, and I hope this was helpful in how to your lab report with a good grade. Have a good day.